Good morning. Today we are going to talk about potentiation, okay? So, when we have addends like 2 plus 2 plus 2 plus 2, we can represent this addition by a multiplication, right? So this is an addition of 4 addends that all the addends are the number 2. Okay, so I can represent 2 plus 2 plus 2 plus 2 as 4 times 2 because the number 2 appears 4 times, and this gives me 8. But when I have a multiplication like 2 times 2 times 2 times 2, I can represent like a potentiation. So the number 2 appears multiplied by itself 4 times, and then represent like this. We say that the number 2 elevated to 4, it's equals to 2 times 2 times 2 times 2. So 2 times 2, 4, times 2, 8, times 2, 16. So potentiation, it's a representation of a multiplication where we repeat the same number in the quantity of times that appears in the exponent, right? If I write, for example, 2 elevate to 3, or 2 at cube, what does that mean? It means that number 2 is multiplied by itself 3 times, and then this gives me number 8, right? So this is the definition of potentiation. I have the base, I have the exponent, and I have the power, the result of my calculation. The number 2 is my basis, number 3 is my exponent, and number 8 in this case is my potentiation. Let's see some other examples. If I have 5 times 5, this is the same as 5 elevates at number 2, and 5 times 5 is the same as 25. If I have 3 times 3 times 3, 3 elevate to the third number, to the cube. So I have 3 times 3 is 9, and 9 times 3, 27. We just need to take care to not make confusion with 3 plus 3 plus 3, right? This is 3 times 3, which is 9. So the first one is about a multiplication. It's a way to represent a multiplication of factors. And in this case here, it's it's a representation of addends. It does in addition, right? Now, let's say that I think about the 10. 10 times 10, it's equals to 100. But I can also say that 10 times 10 is the same as 10 elevated to the second power, right? I can say 10 times 10 times 10 is the same as 10 elevated to the third power, and this is the same as 1000. If I say 10 times 10 times 10 times 10, the same as 10 elevated to the fourth power, which is the number 10,000. Pay attention that the power I have here is the quantity of zeros I have in my result, right? Look, here's the fourth power, and I have 4 zeros in my result. So in the case of the 10, I don't need to make the multiplication. Yes, I just need to see what is the exponent that I will put that the same quantity of zeros. Let's see another example. 10 elevated to the fifth power. I'm going to put 1 followed by 5 zeros, right? If I say 10 elevated to the 6th power, the exponent is 6, so it's 1 with 6 zeros, so 1 million. So with the 10 power, it's just we see the exponent and we put that quantity in the quantity of zeros in my result, right? Now, let's see the number 1. If I have 1 elevated to the 2nd power, is the same as 1 times 1, which is 1. If I have 1 elevated to the 3rd power, is 1 times 1 times 1. This is 1 as well. If I have 1 elevated to the 4th power, 1 times 1 times 1 times 1, which is this, it's 1 as well. So, take a look. All the time I have 1 elevated to any exponent, my result is 1. So 1 elevated to any exponent is always 1. Why? Because 1 is the neutral element of the multiplication. Okay? Now, if I have 2 elevated to 0, it's the same as 1. 3 elevated to 0, it's equals 1. 4 elevated to 0 is the same as 1. Every time I have any number elevated to 0, it's 1. Why? This is the definition, right? The same happens like, let's say I have 0 elevated to the 2nd power is 0 times 0, which is 0. 0 elevated to the 3rd power is 0 times 0 times 0, which is 0. 0 elevated to the 4th power, 0 times 0 times 0 times 0, which is 0. So 0 elevated to any power, it's going to be 0. Okay? Like, so if I have the exponent 1, let's say 5 elevated to 1, it's 5 itself, right? So it's 5. If I have 6 elevated to 1, it's 6. 7 elevated to 1, or 7 elevated to the 1st power, it's 7. 8 elevated to the 1st power is 8. Any number elevated to the 1st power is itself number. Okay? 11 elevated to 1 is 11. If I have 10,000 elevated to 1 is 10,000, and so on. Okay? Now, take a look on this. If I have 2 elevated to 0 is 1. 2 elevated to 1 is 2. 2 elevated to the 2nd power is 4. 2 elevated to the 3rd power is 8. 2 elevated to the 4th power is 16. Pay attention that from 1 to 2 I multiply by 2. Then I multiply by 2 again, multiply by 2, and multiply by 2. So take a look that I always, to go forward, I multiply by 2 because my base here is 2, right? Let's see another example. 3 elevated to 0 is 1. 3 elevated to 1 is 3. 3 elevated to 2 is 9. 3 elevated to the 3rd power is 27. 3 elevated to the 4th power is 81. Take a look. Here I multiplied by 3. I multiplied by 3, by 3, and by 3. Okay? But let's say that I want to go back. Instead of going from 1 to 16, I go in the opposite way. I say to you, oh, I know that 2 elevated to the 4th power is 16. I want to know how much is 2 elevated to the 3rd power. So for I go back, I do the opposite operation of multiplication. If here I multiply by 2, 8 times 2 is 16. For I go back, I need to do the opposite operator of multiplication. I need to divide. So that's why here I divide. 16 divided by 2 is 8. Then if I want 2 elevated to the 2nd power, I have to divide by 2 again. It's 4. If I want 2 elevated to the 1st power, I need to divide by 2 again. So it's 2. And if I want to elevate to 0, I divide by 2 again, and I have 1. Okay? Let's see another example. Let's say I have 5 elevated to the third power. This is 125. I want to know how much it is 5 elevated to the second power, so I divide by 5, which is 25. I want to know how is 5 elevated to the first power. I divide by 5 again, so I have 5. And I want to have 5 elevated to the 0. I divide by 5 again, and it is 1. Okay? Let's see. Let's say that I want to know how much it is 75 elevated to the second power. We can do the usual operations. Yeah, we can come here and do 75 times 75. But we have another way of doing it, right? So what can I do? I separate the units from the tens. 5 elevated to the second power is 25. What I'm gonna do now? I'm going to take the number 7 and multiply by the next number, which is 8. And then I do 7 times 8 is 56. So this is my final result. If you don't believe, let's check here. Let's do the multiplication here. 5 times 5, 25, goes 2. 5 times 7, 35, plus 2, 37. 7 times 5, 35, goes 3. 7 times 7, 49, plus 3, 50, 51, 52. Right? And then I have 5, 12 goes 1, 6, 5. So I have exactly the number I found. So when we have a potential that my units is a number 5, I can do like this. Let's see another example. 85 elevated to the second power. I separate the units from the tens. So 5 elevated to the square is 25. Now I'm going to take the tens house and I'm going to multiply by the next number. So I do 8 times 9, which is 72. And then you can check, you can do 85 plus, times 85, you're going to find 7,225. Let's do another example. 115 elevated to the second power. So I split again the units from the tens and hundreds. It's one block, okay? So 5 elevated to the second power is 25. And then I take 11 and I do times 12. 11 times 12 is 132. And then my final result is 13,225. Okay? I hope you have understood, sorry, and if you have any doubts, you ask me. Okay? See you in the next class, and thank you for watching.